So the way we have different languages and different accents and dialects around the world that make it difficult for us to understand each other sometimes. We have different units and quantities and measurements in different parts of the world. So to simplify things, the scientific system of units is used, which is known as the Système International or the SI system. In the SI system, there are 7 base quantities and their units, and these are used to derive all other quantities and their units. So from the base quantities, we can derive other quantities which are known as derived quantities, and their units are known as derived units. So it's essential to know what the base quantities are because they sort of form the building blocks of all the other quantities. So the 7 base quantities are mass measured in kilograms, length measured in meters, time in seconds, electric current measured in ampere, thermodynamic temperature measured in Kelvin, not Celsius or Fahrenheit. Then we have amount of substance measured in mole and luminous intensity measured in candela. So in your course, you will need to know 6 of them. Candela does not really feature in the course, and the first 5 are the ones that will show up in the AS course. And then amount of substance is not present in AS course, but you will have to come across it in the A2 course. So let's talk about units now, and if we looked at the base quantities and their units, you can see that each base quantity has a specific unit. If you look at mass, for example, mass has a base unit which is the kilogram. Now you can see that the kilogram already uses the prefix kilo. The other base units do not have a prefix, only mass has a prefix which is the kilogram. This means that in your calculations, whatever values you have, for example, if you have 500 grams, then you have to convert them into their base unit form. So if I had 500 grams, then I have to convert it into kilograms, so that would be 0.5 kilograms. And that's what I would use in my formulas and calculations in order to arrive at the correct answer. So all your units must be converted into their base unit form. In terms of converting units, we also have to convert areas and volumes. So for example, if I have 1 millimeter, when I convert that into meters, then I get 10 to the minus 3 meters. So that's 0.001 meters. But if I have 1 millimeter square, then in order to convert that into meters square, then I have 10 to the minus 3 to convert the millimeters. Then I also have the square. So minus 3 into 2, that gives me minus 6. So I end up with 10 to the minus 6 meters square. And similarly, if I have 1 millimeter cube for volume, then I have 10 to the minus 3 converting the millimeter into the meter, and then I also have 3 times because it's cubed, so 10 to the minus 3 into 3 gives me 10 to the minus 9 meters cubed. So now that we've talked about base quantities and units, we should also talk about derived quantities and units. So derived quantities, as the name suggests, are derived from a combination of all the base quantities. Now different combinations would give us different derived units, and those would represent different derived quantities. So for example, if we look at speed, now speed is a measure of how fast an object is moving. So the formula is distance over time. Now if you look at distance is measured in meters in base unit form, and this is divided by time. Now time is measured in seconds, so I end up with meters per second, and these are the units for speed. So you can see that 2 base quantities and their units help me derive the unit for speed, which was meters per second. And this gives us an indication of how fast an object is moving. Now similarly, we have acceleration. Acceleration is known as the rate of change of velocity over time. So if you look at units for velocity, which are meters per second, and then this is divided by time, then I have meters per second squared, and those are the units for acceleration. So you can see that in this case we had one derived unit, which was velocity, and this was being divided by a base unit, and together they combine to give us acceleration. Now we can look at this further as well. Say for example, if I wanted to find out the units for force. Now force, a formula for force is equal to mass into acceleration. So mass, as you know, is a base quantity which is measured in kilograms, and this is multiplied by acceleration, which we just looked at, and the units are meters per second square. So I have kilogram meters per second square as the units for force. And another name for this combination of units is also Newton. So newtons are the units for force, and if it were broken down into base units, then it would be kilogram meters per second square. Let's look at another example, and say this time I'm talking about power. Now power has different equations and formulas, and each formula, the units simplify to become the units for power. One example is basically force into velocity. So we just looked at force. Force has units of kilogram meters per second square, and if we multiply that by velocity, which is meters per second, then we end up with kilogram meter square per second cubed, which is the watt. So the watt's identity is based on these combinations of units. So one more example that we can look at now is the units for energy. Now there's different equations for energy. So one of the equations that we use is potential energy, which is mass into gravitational acceleration into height. So we have mgh. Now m is mass, so it's measured in kilograms. G is an acceleration or free fall, which is meters per second square. And then we have height, which is representing a distance, so it's measured in meters. So if we put the units together, this gives us the units for energy, and we get kilogram meter square per second square. Now if I use a different equation for energy, I should also get the same units in their base unit form. For kinetic energy, we have an equation half mv square. So half is just a number, so there's no units to it. But we've got mass, which is kilogram, and then we've got v square, which is meters per second square. And you can see that combining them together, I get a combined base unit form of kilogram meter square per second square. And you can see that this matches the units that we got previously.